Today we're going over Chapter 8, Section 4, Proportionality Theorems. So triangle proportionality theorem states, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So it means that if segment EB is parallel to segment DC, then AB over BC equals AE over ED. So let's draw on this so you guys see some other stuff. If these two are parallel, we know AB over BC and AE over ED are going to be congruent. We just stated. But also remember, these angles are going to be congruent. Those are corresponding angles. All right?
Can I get the door for Jacory?
Another way to write this proportion, guys, is you can write it as AB over AE. So little over little equals BC over ED. So this little and this little, and then the bottom part of the right and the bottom part of the left. Another one you can write it is AE over AB equals ED over BC. There's multiple ways you can write this. So since these two triangles are similar, this is just a proportionality statement about different parts. These two triangles are similar triangles.
I heard you.
So these are similar triangles, so the sides are proportional. So, guys, remember, this is a congruent angle for both of them. So, if we have two congruent angles in two different triangles, we know that this is going to be similar triangles because of AA. So, we know the sides are congruent, which is what I wrote down. You can write them different ways. We have the converse of the proportionality theorem. And it states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So all of this means, remember the converse just means the opposite. So from the previous one, all we're going to do is switch the if and then. So if we flip the if and then, now we have if AB over BC is equal to AE over ED, then we have that EB is parallel to CD. We're just stating it backwards. This was the original statement in the other one, and this was the second. Now we flip them because now we're talking about the converse. So if the proportions are congruent, then the lines are parallel. Before it was if the lines are parallel, then the lines are congruent. We're just flipping the if and then. So here we have example 1. They're telling us these two line segments AB and ED are parallel, and they give it to us with these triangles. Now, we got to state CD is the segment right here, over DA, so the segment right here. We're going to have to put CE is equal to CE. Again, the small one first, and then the second part, which would be EB. Now, for 2, I'm going to erase this right here so we can work with 2 on the numbers. So if it's telling us CD is 3, so 3. They're telling us DA is 6. DE is 3.5. Then AB is what? In this case, I'm going to put an X because that's what we're trying to find. 4. Now, for that one, we're going to do... You guys remember we did the whole thing for the proportion, the big triangle and the small triangle. So I'm going to do 3 over 9 as my scale factor, which is going to simplify to 1 over 3. So I'm going to do 1 over 3 equals 3.5 over x. So we're left with x is equal to 3 times 3.5. Now let's do 3.5 times 3 here. It's going to be 5 point, carry the 1, 3 times 3 is 9, plus 1 is 10. So we're left that with our x is equal to 10.5. So AB is equal to 10.5. Let me fill that in right here.
Wait, how is it 10.5?
And then for C, if CB is equal to 12, so this whole thing is equal to 12, and EB is 8, and we have CD is equal to 6, so we get a new number of 6, then what is the A? We're trying to find this DA in red. So to do that, I'm actually going to use the proportion that we have. I'm going to do, since we're trying to do the 8 and the x, which is what we're trying to find, I'm actually going to end up doing 8 over x is equal to 4 over 6. This is 4. I got that 4 by doing 12 minus 8. When I do that, I am going to cross multiply, so I'm going to get 4x is equal to 48, divide by 4, and that gives me that x is equal to 12. This is one way of doing it, guys. There's multiple. Another way you can do it is you can grab this segment right here over 12, do 8 over 12, and that's going to simplify to 2 over 3. And you can set up 2 over 3 as x, and then x plus 6. We can cross multiply into getting 2 times x plus 6 is equal to 3x. That's going to simplify to 2x plus 12 is equal to 3x. I'm going to subtract the 2x from both sides, and I end up with, I'm going to write it up here, 12 is equal to x. So I'm running out of space. So we get the same thing 2 different ways. Either one is valid. I use the red one as the theorems that we have just learned, the proportionality theorem. But if you want to use what we did in last section, the entire triangle and the small part, that's fine too. You just have to make sure that you set it up correctly in order to solve it properly. All right, now we have theorem 8.8, and it's 3 parallel lines theorems. This theorem states that if these parallel lines intersect 2 transversals, then they divide the transversals proportionally. So, as you guys know, we have parallel lines and transversals, so that means that all of these angles are going to be congruent, right? Because those are corresponding, same with these. Now, for the other line, which is at a different angle, they're going to be different. It's going to be these angles with each other and the opposites that I didn't mark for each one. So if they tell us BC over CD, BC is this part right here, and CD is this part right here, equals AF, which is this part right here. I should probably do it in a different color. Equals AF, which is this small part right here, over FE. So this is the top of the figure, and this is the bottom of the figure. They're telling us all of those are congruent. We can actually change the order up into many different ways. I'm going to do a few. I can do AF, for example, so the top left one, over BC. So the top with the top on the left side, and I can do FE over CD. So I did the left side and then the right side on the fractions. You can also do it the opposite. You can flip the bottom and the top. You can do, I'm going to put it up here, EF over AF. So EF, AF, so again, the whole thing, I just flip them, equals DC over CB. So again, we end up just flipping the proportions, either the bottom or the top, like we've been doing. Doesn't matter which one goes on top and which one goes on the bottom, as long as you're consistent. I put either all of the things on the left to the left and all the things to the right on the right. It doesn't matter as long as you're consistent. Example 2. They are telling us that A is equal to 2. A is the segment, so I'm just going to mark it in blue. They're telling us B is equal to 3. They're telling us C is equal to 5, and they want us to find D. So there's different ways you can do it. I'm just going to set it up as the top over the bottom, and then I'll show you different ways. So 2 over 5 would be equal to 3 over D. Cross multiply, 2D equals 5 times 3 is 15. So I get D is equal to 15 over 2. which that's fine, that's the answer. You can either leave it like this, 15 over 2. You can either leave it like this, simplify to 7.5, simplify to 7.5. Honestly, I am okay with this version of fraction. I will never take points off for an improper fraction, guys. You can honestly leave like this. Now, I also want to show you another way that you can do it. You could have done it the entire left side and then the entire right side. So I could do, for example, 3 over 2 equals d over 5. And I end up multiplying 5 and 3, that's 15. Again, in 2d, which leaves us again in the same step, which leaves us to d is equal to 15 over 2. I can do it another way. I can do 5 over 2 over d over 3, so flipping these. As long as I flip the top and the bottom and I flip this one too, it's also okay. There's multiple ways of doing it. I'm not going to show all of them, but these are just 2 of the ways, or plus 3 if you count the ones you flip. And you're still going to get the same answer. Now, for B, we have, if A is 4, so I'm just going to do it in red, different colors. B is 8, C is 5 again. They want us to know what C plus D is. Now, in order for you to do C plus D, we first have to solve for D. And then we're going to do, so X is going to be C plus D. We can solve for X and then plug in C and solve, and then we'll find what C plus D is. So, I can do, let's do 5 over X, why not? Let's call it X instead of D. And then do 4 over, since I said the X is C plus D, I'm going to add these two to get 12. 4 over 12. I can cross multiply. You can simplify the 4 and the 12 first. You don't have to. If you were to have done it, this would actually become 2 over 3. So you end up with 5x equals 2 over 3. So you end up with, hold on, I did something wrong in simplifying it. I'm just going to go ahead and do it from here. You're going to get 12 times 5 is going to be 60. And 4x is just 4x divided by 4. Divide by 4, and I get that x is equal to 15. Now, that since x is already C plus 10, that would be our answer. Now, if you by any chance did not want to do it like that, and you wanted to do 4 over 8 equals 5 over d, that's fine. Cross multiply the 8 and the 5, it's going to be 40 equals 4d. Divide by 4, divide by 4, and I get that 10 is equal to d. Now, d is not what they're asking for. They're asking for C plus d. So I end up doing x is equal to 5 plus 10, gives me 15. Same answer. So there's multiple ways you can do it. Again, you can either do the addition of the whole sides like we've been doing in the past, or you can take them for separate and then add it at the end. Just make sure you know what they're asking for in order for you to give the right answer. We have theorem 8.9, triangle angle bisector theorem. States that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the length of the other side. So if they're telling us AD, so this whole thing over DB is equal to CA, so this whole thing over CB. So they broke it up into 4 parts, this triangle. But again, it's based on the angle bisector. So, what is it saying? If this divides it perfectly, like that, into an angle bisector, remember the definition of an angle bisector means it divides the angle perfectly in the middle. You're going to get segments that are the same. They're going to be proportional. Not the same. They're just going to be proportional one to another. So, like it said right here, I can also do, for example, AD, so this small one right here, over AC, so this long one right here, equals DB over BC. So I just flipped the order. I went DB and BC being the whole thing. I don't have to do the whole CB at the end. So it's going to be proportional. I can also do CA over AD equals CB over DB. Again, just flipping things over. it's all going to be a variation of this original one. If you notice the bottom one, these two are flipped. And if you notice in the top one, these two are flipped. So it's honestly always going to be a variation of the proportion that's in the PowerPoint right now. So it's not going to matter because at the end of the day, you're going to just end up multiplying the same things anyway. I don't know if you notice, in all of these examples, we end up multiplying AD with CB when it comes to solving the proportion, and we end up multiplying DB with CA when it comes to solving the proportion for any of the setups that we have here. All right, so for example 3, they're asking us to find X. So we can set up the proportion different ways. I'm going to set it up, since X is the whole addition of 10 plus this side. I'm going to call this side, I'm just going to call it Y. So now that I call this Y, I'm going to actually set up 12 over 10. So I'm going to do the left side of the triangle to the other. So like I was saying, 12 over 10 is equal to 24 over Y. I'm going to go ahead and cross multiply, and that's going to, actually before I cross multiply, I'm going to simplify this to 6 over 5 over 24 over Y. Let's make our lives easier by simplifying. We're going to cross multiply, and we're going to get 6Y is equal to 24 times 5. Now 24 times 5, I don't know out of the top of my head. So it's going to be 120, which gives me 6Y is equal to 120. Divide by 6, divide by 6, and I end up with Y is equal to 20. Now, that is not the final answer, though. The final answer is X. Now, at the end, X, if you notice, is just 20. So X is just 20 plus 10. So we end up having as X is equal to 30. That would be the final answer, and that would be perfectly fine for you to solve. Now, if you wanted to do it a different way, for example, setting it up differently, I'll just do it real quick on the bottom. You can set it up, let's say, as 12 over 24 equals 10 over Y. Again, I'm going to cross multiply here, so I'm going to get 12Y equals 240. I'll divide by 12, divide by 12. I end up with Y is equal to 20. So again, same thing, which will lead us at the end again to do 20 plus 10 to get the 30. Now, another way you could have set it up to solve for that Y or solve for the X, you can say that it's going to be X minus 10. So you can set it up again as, let's say, 24 over X minus 10. That's to find this segment right here. Equals 12 over 10, we get 240 equals 12 times X minus 10. We're going to get 240 equals 12X minus 120. And at the end of the day, I'm running out of space. You will end up with the same answer. All right, since there are no questions, I want you guys to know you do have homework on Canvas. It's already out open. And that would be it for today's lesson.